Swifters, in this video we're going to become string superstars. Working with strings are among the most useful skills in programming. We often want to compare or manipulate text, so in this lesson we're going to pull up a playground, and even though the work that we'll do will be directly related to word garden, this video can also be viewed as a standalone lesson on string manipulation and working with strings, and you'll learn a bunch of techniques that you'll definitely want in your Swiftie repertoire. Now we're going to learn to search inside strings using contains, HasPrefix, and HasSuffix. We'll learn to alter strings with RemoveFirst, RemoveLast, and replacing occurrences of with. And we'll produce modified strings getting capitalization just right with uppercase, lowercase, and capitalize. We'll also learn to iterate through strings. We'll create a string using a repeated value, and we'll use escape characters. Now we'll also have a couple of challenges right at the end, and we will use the results of those challenges in the next video. Now Swifters, I don't want to string you along any further. Let's code! Let's create a new playground, so we'll go up under File, New, Playground. This will be a blank playground. Select Next. I'm actually going to save this inside of the first level of my word garden folder, and when I push and commit, I'll make sure that I add this to my repo. This way I've just got these notes that are saved up on GitHub too. I'll give this playground the name String Manipulation. So click Create, expand the window, and we're ready to code. And the first thing I'm going to show you is the contains method. So we're going to see if my last name contains laugh. Spoiler alert, it does. It's an unusual spelling of Gallagher, but we'll use that as a feature and not a bug to demonstrate the contains method. So we'll change the str up here to var my name equals GALLAUGHER. On the next line, we'll create the smaller string we're searching for, so we'll say var smaller string equals laugh. Now to check to see if my name contains smaller string, it's incredibly easy. All we do is type in my name and dot. I wonder if there's a contains. Sure enough, there is a contains method. We actually see a few of them in here. Let's go ahead and select this one with the string protocol. Since we're not looking for an individual character, we're looking for a string inside of a string. Notice just to the left of contains, it says that this is going to return a bool value, so it will be true if our string contains the string that we're sending inside of these parentheses. Now the description and code completion is a little jargony. You can read through it. It does say that the search is case sensitive, so that's important, but essentially just know we're searching for the string that's in between the parentheses to see if it's inside the larger string that this is called on. So press return to accept this. Smaller string is what should be between the parentheses, open and close curlies. And another quick note, so contains doesn't just work on strings, it'll also work on arrays. So if you pass this in as a method on an array, you could put any element if you want to check to see if that array contains the element that's in between parentheses. Now we're working with strings in here, so why don't we go ahead and say print, and we'll do string interp contains string interp, and in the first string interp we'll put my name, and in the second string interp we'll put smaller string. Then after this we'll say else, open and close curlies, print, and in between the quotes, we'll say, there is no string interp in string interp. And the first string interp will say smaller string. The second one will say my name. Let's do a shift return. See how things show up. First run is always the slowest in the playground. And it says Gallagher contains laugh. Now, there's this terrible comic back in the 70s, a guy that used to smash watermelons named Gallagher without the U. Most Gallaghers are spelled without the U. Let's remove it. We'll shift enter again down here. It says there is no laugh in Gallagher, spelled like the watermelon guy. That watermelon smashing thing wasn't all that funny. You can look it up on YouTube if you want. I don't recommend it. Things are looking good though. You know how to use contains. Now our playgrounds act as a nice set of notes for us, so let's put a comment above our demonstration of the contains method that says contains. Then below here, we'll put in another comment we're about to show HasPrefix and HasSuffix, those two new methods. And we'll demonstrate this by searching for a substring in an occupation name. So we'll say var occupation equals Swift space developer, and then below that we'll say var search string equals Swift. So one of these methods is HasPrefix. What do you think that does? It'll tell you if the string has the prefix. So let's go ahead and print, and in between the parentheses, we'll say occupation.HasPrefix. For some reason, code completion doesn't offer a description of HasPrefix, but again, it's pretty self-explanatory. In between the parentheses, we'll put in search string, then we'll shift return, and this just returns a Boolean value, so it says true. That's because occupation does have the prefix search string. The word Swift is the first part of the occupation Swift developer. So here's an expanded example. We can say if occupation.HasPrefix, passing in search string, open and close curlies, print, you're hired. Else, open and close curlies, print, no job for you. Shift Enter, and we see in the console you're hired because the search string Swift is inside of the occupation Swift developer. May you have similar success in your career. But what if the occupation was real estate developer instead of Swift developer? Shift Return down below. No job for you. And in order to delineate these different examples, I'm going to replace this Boolean value here with print, and I'll just put in prefix search in capital letters, and then down below I'm going to show you the suffix search for HasSuffix, so I'll say print, and then capital letters, suffix search, and just below this we'll reuse our variables, but we'll say occupation equals, this time iOS developer, and search string equals developer. And HasSuffix works just like HasPrefix, so I'm going to copy this whole 5-line if clause, paste it down below. I'll backspace over HasPrefix and replace that with HasSuffix. You see how that shows up here? Again, no description in code completion, but again, we know what it does. It returns a bool. Press return. We'll check to see if the suffix is search string, so that's what we'll pass in here. And why don't we modify our print? We'll add to the first print statement, we need more string interps occupation, and then down below we'll say, no one needs any string interps occupation. Shift return, you're hired, we need more iOS developers. Of course that's the case. And it would be nice if we spaced out our results in the console. Why don't we put line feeds just before these print statements that are in all caps? And the way that we'll put the line feeds in is we'll use the escape character for a line feed. That's /n in between the double quotes. Whenever we encounter that, we give a line feed. It's sort of like we press the return key. There are actually several escaped characters. They're really useful if you want to include a character in a string that's difficult to type directly between quotes. So you can see a list of them here. They all start with a backslash. Feel free to experiment with them on a playground on your own if you'd like, but for now we're only concerned with the /n. That's the escape character for line feed. I find it helpful to think of the n as representing new line. So just after the first double quote in prefix search up here, we'll do /n. We'll do the same down here for the suffix search as well. Shift return. We see that things are spaced out nicely. /n. Escape character gives us line feeds. Now just to make sure that the false condition is working in here, we can change iOS developer to iOS hater. And if we do a shift return, we can see no job for you. No one needs any iOS haters. On to our next method, we'll put a comment in here saying it's going to be RemoveLast, and we'll say print, escaping character with the /n, remove, and let's go to the world of rock and roll for our next example. So we'll say var band name equals the White Stripes, and then we'll remove the last character. We'll imagine Jack White goes on his own, so we'll say let last char equals band name dot RemoveLast. Look what shows up here in code completion. It says removes and returns the last element of a collection. Again, it says element and collection because you can also use this on arrays and other collection types. Now, a string is considered to be a collection, so what this is going to do is it's going to remove the last character in that collection, the last character in the string, and it modifies the original string. So this tells you a few things. One, you cannot call it on a constant because it's going to modify the original string, and also, take a look, it returns the value. So if you wanted to get what that last element was, the last character, for example, you could put that in another variable or constant, or use it in a calculation, and if you don't need the character that was removed, just ignore it. So let's press return to accept this, and we'll say print. After we remove string interp, that'll be last char inside here. The band is just string interp, and we'll put band name inside. Then shift return, and in the console it says after we remove S, the band is just the White Stripe. That's the RemoveLast method in action. Now there's also a remove first that will remove the first element in an array or the first character in a string. So here's our comment for that, but there's a bit of a tweak here. We can also say, like this, dot remove first, this works with last too, and pass in an integer in between the parentheses. That will remove the first or last, if it's removed last, number of characters or number of elements in the array. So we'll put in a print statement to remind us what we're doing in here. We'll say print, and then /n, remove first number. Oh, as our example, why don't we revoke the license of the worst doctor in the history of cartoondom? So we'll take Dr. Nick from The Simpsons, and we'll remove his title so that he is no longer a physician. So we'll say var person equals, and in quotes, Dr. Nick, and then we'll say let title equals, and that'll be doctor, spelled just as the abbreviation is above it. Now we can write this so that we can remove any title from any person string, and we'll do that with the statement person.remove. Now notice we got a couple of remove firsts. This remove first down here with just the open and close parenthesis is just like the remove last that we just used. It removes the first character or element in the array, We don't want that though. We want this first one that says remove first, and then in parentheses it says k:int. Now the void to the left of this means it doesn't return any value, but note the code completion description above removes the specified number of elements, characters when it refers to a string, from the beginning of the collection. Press enter to accept this, and now if we want to remove any title that we could put in there, we could just refer to title.count, and it'll remove the number of characters in the title from the start of our person string. Let's see what this looks like. Let's do a print person just below, and we'll get one quirk here. We'll see remove first number, and look, it says space Nick. So what do we need to do to make sure that we remove that space in front? Just add 1 to title.count. Shift return again, and there we go. We see that we have taken away Dr. Nick's license. He is now just Nick. Now we'll put another comment in for our next topic. That's going to be the replacing occurrences of with method. So down here we'll also put in a print statement with \n replacing occurrences of. Now this is a super useful method, especially when it comes to data cleaning, because remember, you could have multiple strings that mean the same thing but that are spelled slightly differently. And a lot of times when you work with machine learning or data mining and data comes from different sources, you may have data that's recorded with different conventions. And here's an example in the comments. We have 3 addresses which are identical, but the first one uses the street abbreviation ST period, the second one is just ST as the abbreviation, the third one spells out the word street. Now a human looks at these things and says, those are all the same address. A computer looks at these things and says, those 3 strings are different. Want to use this data? You got to clean it up. You want to clean it up? Replacing occurrences of with is a great method to use. So let's test this out with an address variable. We'll say var address equals, and we'll use this first option, 123 James Street, spelled capital S, lowercase t, period. Then we'll create a variable street string, and this will be the variable that we search for to replace. So we'll say that equals, and we'll use the same abbreviation for street above, capital S, lowercase t, period. And then down below we'll create a replacement string. We'll say var replacement string equals, and this will be the full word street spelled this way, capital S, lowercase t-r-e-e-t. Now let's put our modified address into a variable we'll call standard address. We'll say var standard address equals, then we'll say address dot replacing, look what shows up here. We want this option replacing occurrences of with. We can see code completion says returns a new string, so it doesn't change the original string, but it returns a new string with all the occurrences of the target string. You can ignore the stuff about the range, but it says replaced by another given string, and that other replacement string is what follows the with argument. That's what we want. Press return to accept this, and right after of, what we want to pass in here is street string. So that's what we're going to be searching for. We're going to replace that with replacement string. Again, you read this just the way that it's written. Take a look at the string address and replace any occurrences of street string with replacement string. Then why don't we print out standard address, comma, address, shift return, and we see 128 James Street. The replacement string is in there versus the original, which was 123 James with ST period, the abbreviation. Nice. Now here's something for you to consider. I'll put it in a comment here, but it's also listed as one of the exercises at the end of the written material in the online book. What would you do if we had 123 St. James Street? See how we've got ST period as the abbreviation for street at the end, but also ST period as the abbreviation for saint. Give that a try in the exercises at the end of the section and see what you come up with. So next up, we're going to iterate through a string, so we'll put in a comment for that, and I'll also put in a print statement here that recognizes we're going to show you how to do a backward string. First, let's show how we can iterate through a string the front way, and it's the same way we iterate through an array. So what we'll say down here is for letter in name, open and close curlies, and we got to define our name string, so up here we'll say var name equals, and I'll just use my last name again. Then between the curlies, we'll say print letter, and shift return, and we see each letter in my last name prints out in a separate line. Now, if you want to quickly challenge yourself, you might think, hey, can I go ahead and print the name backwards on a single line so that it's spelled backwards? If you want, you can pause and you can try that. One quick thing to pay attention to, though, if you option click on top of letter, it doesn't say it's a string. It says it's a string.element, which really is a character. So think about that. You can pause, resume when you're ready, and let's see how you did. So before our for loop, we'll create a variable backwards name. We'll set that equal to the empty string, and then inside the body of the for loop, we'll say backwards name equals letter plus backwards name, but remember what we've got to do to letter. we've got to convert letter to a string. And you see the error we get down here, cannot convert the value of type string.element, which is also known as a character, to the expected argument type string. So we can either put the type name string out front, wrap this in parentheses. You could also use string interpolation if you wanted. Then on the line below, let's print these side by side. So we'll say print string interp, comma string interp, and in the first one we'll put in name, and in the second one we'll put in backwards name, shift return, and we see Gallagher spelled forward, Gallagher spelled backward. Nice. And just to show you another way to do this, you could have used the dot reversed method after name in the for statement and constructed things this way. Now, working with capitalization is also important too, especially because string equality includes capitalization, so something with uppercase does not equal something with lowercase, even if the letters are otherwise the same. So we'll put in a comment for capitalization here in a print statement with \n that says playing with caps. And then in the next line, let's go ahead and define some values. So we'll say var crazy caps equals, and I'll put in Swift developer, but I'll scramble up the capital letters and lowercase letters. Then on the second line here, I'm going to use the uppercased method. So I'll say var uppercased to create a new value equals crazy caps dot, and I'm going to type uppercased. I want to use this first method here with empty parentheses, and we see that this is a method that returns an uppercased version of the string. So it doesn't change the original string, but it gives us another version that will be in all uppercase letters. We'd like to see this, so press return. On the next line, let's look at the lowercase. So we'll say var lowercased equals crazy caps dot LOW, and sure enough, there is a method called lowercase that returns a lowercase version of the string. Let's press return to take a look at that one too. And finally, we can also capitalize each word if we'd like to do that as well. We'll say var capitalized equals crazy caps dot, and we'll start to type in cap, and we see capitalized shows up here. Code completion's description says a copy of the string with each word changed to the corresponding capitalized spelling is what we get. Curiously, this is a computed property. It's a variable. See the V over here instead of a method. The previous values were methods. Those were functions on a type, so functions need to have the parentheses. That's why we've got empty parentheses up top. Now, I don't know why the geniuses behind the Swift programming language decided to make uppercase and lowercase methods, but to make capitalized a computed property. One of my former students is on the Swift UI team. I suppose I could ask him. But regardless, Xcode will go ahead and insert the parentheses if we need them. We don't need them here. We'll press return. Thanks, Xcode. We'll move on. Then down below, let's just print out our values. So we'll say print crazy caps. Then on the next line, print uppercase, lowercase, capitalized, shift return. And we see the crazy cap Swift developer, but down below we have it in all caps, all lowercase, then just the first letters capitalized. You know what, just to show you that crazy caps wasn't changed too, I'll cut it out from the line above the printing of the three values and I'll paste it below, shift return again. We see crazy caps wasn't changed at all, but we were able to return values that were changed by the methods or that calculated property. Nice and very handy. So now let's use some of what we've learned about strings and iterating through strings for another challenge that we will leverage in our Word Garden app in the next video. So in our Word Garden app, the words that a user is challenged to guess will show up in our word being revealed label in its text property as underscores with spaces in the middle. So for example, if the word guessed is Swift, S-W-I-F-T, then word being revealed.text should show as 5 underscores separated by spaces. Now, assuming that the word going into the label is held in a variable named word2guess, write a routine that will return a value into a new value named revealed word that contains an underscore for every letter in word2guess with a space between each dash. You could just write this right in Playgrounds. You don't even have to write it as a function. Why don't you pause here, give it a shot, resume when you've given this a try, and now let's look at a solution. So let's create our two variables. We'll say var word2guess equals, and we'll use Swift, all caps, and on the next line we'll have var revealed word, and this will start off as the empty string. Now let's iterate through all of the letters in word2guess. So we'll say for letter in word2guess, open and close curlies. And we could do a few things inside the curlies. Why don't we start off with revealed word equals revealed word plus, and then in between the quotes we'll say underscore space. Then down below, why don't we print out string interp word2guess will show as string interp revealed word, and we'll put single quotes around the revealed word. We'll do a shift return to run this and look at our result. We have an extra space at the end of our revealed word because for each letter we add an underscore and a space. Now we could use this method, but we'll always have an extra space at the end. But we know how to get rid of that space. Remember how? Let's do this on this line just above the print statement. We'll say revealed word dot remove, and we see one of our options is remove last. Code completion offers us a reminder. The description says removes and returns the last element of a collection. Now the collection is the string, so by removing the last element in the string, it's really removing the last character. Now we don't care about what's returned here, so we can ignore that, but we definitely want to remove the last letter in the string, and it does this on the original string. It doesn't make a copy of it. Press return, this is what we want. Shift return to run our code, and we get our result without that extra space at the end. Perfect. Now there are lots of different ways to code this and get the same result. One thing to point out too is that we actually didn't need letter in here because we never used letter inside of the for loop. We could have just put the underscore character in here. Remember, underscore acts as an unused placeholder. If we do a shift return again, we see that we get the very same result. Now here's another alternative where we don't even need the remove last line, so I'll comment that out first. We could start with revealed word starting with an underscore, and then each time we go through the for loop, we can add space underscore. Now starting with an underscore and adding a space underscore for each letter in word to guess will actually give us one more space underscore added to the end of the revealed word string than we need. Now this isn't quite right, but here's what we can do. Instead of iterating through the word to guess, which goes through once for each letter of word to guess, we can instead iterate on a range that is one character less than the number of letters in word to guess. So we can do that by replacing word to guess with 1 ... word to guess .count -1. Now this will work. It'll also assume that any word to guess has at least 2 letters in it, because if you had an empty string or just 1 letter, we wouldn't be able to get a valid range when we do word to guess .count -1. Now let's do a shift return. This works great too. Now let me show you one more super efficient method that doesn't involve using loops at all. It involves using a technique that we could use to create a string based on repeating characters. So I'll scroll up, give ourselves a little bit more room here, and I'll put in a comment that says create a string from a repeating value, and we'll say here revealed word equals, and then we'll put double quotes with an underscore in it because every revealed word begins with an underscore. And now here's how we can create a string from repeating values. So we'll say plus, then we'll give the type name string with a capital S, and we'll type an open parenthesis. Now what this reveals is a bunch of different ways that we could create strings, and there are a ton of them in here. These are sometimes called initializers because we're initializing a new string. And if we keep scrolling, we can see that the stuff inside the parentheses is alphabetized. We want to find repeating. Now notice we've got more than one choice that begins with repeating. And we want this second one, which is repeating : string, because we want to repeat a string, not just a single character. And the count is how many times we want to repeat it for. See the description? Creates a new string representing the given string repeated the specific number of times. That sounds great. Let's press return to accept this. And for repeating, we'll put in between quotes space underscore, and for count, we'll say word to guess .count -1. Then down below, let's print out the result, and we'll provide some text in here to indicate that it's different from the one we've got above. We'll say print, and in quotes, using repeating string, : string interp, and in the string interp, we'll say revealed word. We'll surround this by single quotes, and then do a shift return, and we see down below, we've got this new line, using repeating string. It looks exactly like the one above, but what we've done here is we've created the repeating string with one line, where previously it took us 5 lines of code. Nice and super efficient. So this example gives you yet another technique or yet another arrow for your Swifty quiver. Nice! And now we've got our final challenge, the reveal word after last guess challenge, and we're going to use this code in our Word Garden app as well, but we'll first solve the challenge in the playground, and then we'll add the code to Word Garden in the next video. So in our Word Garden app, as the user guesses a letter, we'll add the letter guessed to a string named letters guessed. Now what I want you to do is to write a routine, it doesn't have to be a function, that will go through all of the letters in the variable word to guess, check to see if that letter has been guessed. Hint, you're going to check to see if the letter in word to guess is in letters guessed. And if it is, reveal the letter. If not, show an underscore, add 1 space in between each letter or underscore, and store the end result in a variable named revealed word. Now as an example, the image at the right shows what would be revealed, that's this string here, if the user had guessed the letters S, Q, F, T, and X. In other words, if we pass in letters guessed equals S, Q, F, T, X, and word to guess equals Swift, all uppercase letters, then your code will set up revealed word as this string, S __ FT, with spaces between the letters and the underscores. Give it a try, Swifter. Pause. Give it your best shot. I know you can do it. Resume. Let's see how you did. So we'll start with a comment here, reveal the word. We'll put in a print statement that says also reveal the word. And let's set up some of the values we'll use. We'll say word to guess equals Swift. We already defined that, so we don't need a var. But on the next line, we're declaring a new variable. So we'll say var letters guessed, and we'll say initially that equals the same thing that we had in the challenge slide, SQFTX. And then underneath that, we'll say revealed word equals empty string. We'll start with nothing in there. Then we'll put in a comment, loop through all the letters in word to guess. And then the way that we're going to loop through all of those letters in word to guess is we'll say for letter in word to guess, open and close curlies. And so we're checking every single letter in word to guess. And what we want to do is we want to see, hey, does that letter exist inside of letters to guess? Or does letters to guess contain the letter in this iteration of word to guess? So let's put in a comment here to indicate what we're doing. Check if letter in word to guess is in letters guessed, i.e. did you guess this letter already? And if letters guessed dot contains, remember that guy from earlier on in this video, letter, then open and close curlies. If that's true, we'll put in a comment to remind us. If so, add this letter plus a blank space to the revealed word. We'll say revealed word equals revealed word plus string interp space, and we'll put letter in the string interp. Then after that if curly, we'll say else, open and close curlies. If not, add an underscore plus a blank space to revealed word. So we'll just say revealed word equals revealed word plus underscore space. Then down after the close loop, we'll put in a comment because we need to remove the extra space at the end of revealed word. We know how to do that. We'll just say revealed word dot RemoveLast. Now let's print out these different values. We'll say print, and let's do string interp, and I'll just copy and paste this 2 more times down below, and then I can copy the values that I want to print out above. So we'll say word to guess in the first string interp, and in front of that we'll say word to guess equals. Down below we'll say letters guessed, so letters guessed equals letters guessed. Then down below that we'll say revealed word equals revealed word. Shift return, and look at what we get here after reveal the word. So the word to guess is Swift, the letters guess SQFTX, revealed word is S underscore underscore FT. What happens if we change this a bit? Let's add a W to the end of letters guessed. Does this change anything? Shift return at the end, and it doesn't, other than we see W at the end of letters guessed. What if we guess a bunch of letters that aren't in the word? QXRLM. Shift return at the end, and now we see the revealed word is all underscores. Now I'll scroll up, I'll Command Z to undo to get back the previous letters that I'd guessed, but I'm going to change word to guess. What if instead of Swift, I put in Star Wars as one word? May the Force be with you. Shift return, and look at that, it recognizes S, T, W, and S appears twice in revealed word, even though it was only guessed once. That's exactly the result we want. Swifter, you are now string sorcerers. Let's move on to the next video where we can take the code you just wrote and put it into the Word Garden app. Keep at it.